Giant rivers that flow through the sky mapped for the first time. These are known as atmospheric rivers. Filaments of intense moisture transport in the atmosphere can now be automatically detected by satellite observations by NOAA. And this is a NOAA image, as we can see. This is, of course, over the Pacific Ocean. Now, rivers of intense moisture went their way through our atmosphere just as their liquid counterparts do across the land. Unfortunately, the sky streams are much harder for us to see. Often a product of cyclones, atmospheric rivers can dictate where intense rain will fall, making their lack of visibility a problem. Understanding them grows increasingly important as our warming atmosphere soaks up even greater amounts of water, forcing these aerial waterways to change course. Until now, researchers relied on computer modeling to predict where this water vapor likely flows, but researchers have now devised a way for us to spy on them in real time. The missing piece of the puzzle was a 3D windscape. University of California atmospheric scientist Wei-Ming Ma and colleagues determined satellite records of spatial temperature distributions could be used to create an approximate real-time 3D wind field. Combining that data with NASA's satellite moisture detection revealed a global distribution of moisture-laden currents. Most of the sky's moisture is transported across latitudes by atmospheric rivers as they flow polewards, and they're responsible for up to 30% of annual precipitation in the US and Europe, and as much as 40% in East Asia's wet season. Atmospheric rivers typically form over tropical oceans, but when they hit the skies above land, they often create weather hazards like damaging winds and flooding. As the jet stream over North America has shifted north over the last 4 decades, the atmospheric river frequency over the eastern United States has increased. These sky rivers also influence sea ice variability. Their presence increasing levels of melt. In the last few years, sea ice has been reaching ever-diminishing record lows on both poles. Analyzing the sky streams made visible, Ma and the team can now see previous models had been overestimating the frequency of rain atmospheric rivers produced by underestimating the rain's intensity. As the quality of the satellite observations continues to improve, the methodology presented here can be applied to other satellite observations, such as geostationary satellites, to develop high resolution or higher frequency atmospheric river statistics, Ma and his colleagues explain in their paper. Their new method can now be integrated into weather forecasting and climate models. The researchers plan to evaluate how climate models fare against their new method of atmospheric river detection next. This research was published in the Journal of Geophysical Research Atmospheres, and this is by Tessa Koumanduros on Science Alert. Please leave your comments, and thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support, and that you find all my content so interesting. You'll find the Patreon account details in the description box below.